Astronomers recently discovered 7 new planets orbiting a single star. It's thought that all these 7 planets might have the potential to support water on the surface because they're neither too hot nor too cold in temperature. And 3 of the planets are thought to be in what's called the habitable zone, which is where conditions might be suitable for life. They all orbit a star called Trappist 1, which is a low-mass, cool star located about 40 light years away from Earth. Well, we're very lucky today to have someone with us in the studio who can tell us more about this recent fascinating discovery. Daniel Hestroffer is an astrophysicist with the Paris Observatory, and he joins me now. Daniel, first of all, tell us a little about these planets. How big are they? How old are they compared to planet Earth?
Hello. Well, the planets are big about the size of the Earth, between Mars and Earth in general. That makes also the big discovery of these new planets around this star. They're older. We don't know exactly the age of the planets, but the star is old about half a billion years or 500 million years, so much younger than the Sun or the solar system.
Wow.
Well, but of course, we have many stars in our galaxy with different ages, and we can get this age. So the formation of planets can begin quite soon after the formation of the star. It's something that goes a bit together. So there is no big surprise on the age of this star. It's,
and just give us an idea, how old is planet Earth?
4.5 billion years.
Wow. Yes,
about. Okay. So, yeah, it's quite old. And the life on Earth started really recently in this long history. And then the first human or mammals also even more recently. And so what is interesting, and you make a very long resume, is that we know a lot of planets around other stars, exoplanets, more than 1,000 now. But they are very, very different. We have a very big zoo since 20 years ago, or a bit more than 20 years ago, with the first discovery of exoplanet that was done by telescope in France.
So exactly what is an exoplanet?
Exoplanet is a planet around a star that is not our star, not our sun.
I see,
from outside of our solar system.
Right. Now, how will we find out whether these 7 new planets can support water or not? How do you go about finding out that?
Well, the habitable zone is kind of a definition that helps us at least to categorize some of the planets that are in a good zone with respect to the star in terms of distance and depending on the temperature of the star, that water can be liquid on the surface of a planet. And for that also, it's worth to mention that we have generally 2 kinds of planets called gaseous planets like Jupiter or Saturn and Uranus, which are really big planets with a lot of atmosphere, and we don't expect to have any life originating in this kind of gaseous planets. Or other like terrestrial planets or telluric or rocky planets. For those, we are looking to have this kind of planets in the habitable zone where water can be liquid. We know there is water a bit everywhere in the universe, but we don't want the planet to be too close to the sun. Water would evaporate, or too far from the sun, the water would just freeze. So we want liquid water. And in this habitable zone, water could be liquid. That's the main point. And we guess that water is the best medium to start to have life. We don't know any other example for the moment.
Right,
but,
that's the best indicator.
So we are looking for this kind of planets, and Trappist has a lot of small rocky planets the size of the Earth, between Mars and Earth, and 3 of them are in this habitable zone. Now we are really, let's say, excited. These are the good candidates.
And how come we didn't know about this planet before? How do you find a planet?
So it started, it's a technological challenge. The observation, the techniques are well known. It started about 20 years ago at the Observatoire de Paris in France with a team of Swiss colleagues that used what we call the radial velocity. We measure the velocity of the of the star that is hosting a planet, and we look at very subtle, very tiny effect on the variation of this velocity with respect to the Earth. And then we had other techniques with satellite Corot, or now also with Kepler. We are looking to some other subtle effect that is the transit of the planet in front of the star. And we see a small dip in the brightness of the star that is due to the fact that it is a little bit hidden by a very small spot that is compared to the star. The size of these planets is very small, but it makes a very, very tiny dip in the brightness, and we measure this. And so we are looking to some specific stars. The quieter they are, the better it is, but because if not, there would be too much noise. We wouldn't even recognize a transiting planet or this wobble effect on the radial velocity. So we are looking to some selection, or we astronomers around the world, different teams, are selecting a few stars, and they're trying to find these planets. And luckily, Trappist is another example of a medium-sized telescope that was a ground-based telescope. Trappist is from the Belgian colleague. The name shows that the Belgian origin. And so with the
name of the star was named after a Belgian astrophysicist.
After the name of this telescope they're using to have built. And so they discovered a few of these exoplanets, and then with the Spitzer telescope and larger telescope from VLT, they discovered the other terrestrial planets.
So what other research now will we do on these 7 planets? What more is there to find out? What do you want to find out?
Better characterize, if possible, these planets that we never see directly. We never had the chance to see directly an exoplanet. We just see some side effect looking at a star. And now we would like to have a better idea of the atmosphere, for instance, of these planets, and to see if there is water, or another topic of interest is to see if we can have tracers that are in the atmosphere, tracers of life, or being species on the atmosphere, on the planet.
Gosh.
And that's a point. But on the other hand, maybe to temper a little bit our enthusiasm, it's not that. So it's a very nice discovery to have all these planets in the habitable zone. Habitable doesn't mean there must be life. It's we hope there is a better chance to have that. We can also have to have life underneath an icy planet. We are also looking in the solar system, for instance. And for these planets, they are very close to the star, and so there are some other effects. Maybe there is some big X-ray radiation or ultraviolet that makes the living condition not that easy. And there is also another effect, dynamical effects, for which colleagues in my institute are working on, like Jacques Lascar and his team.
This is at the Observatoire in Paris.
Observatoire de Paris, in Paris Observatory. And we are looking at the dynamics. And one thing that we know in general when we have this kind of system is the tides and the tidal locking. And we have a good example with the Earth and the Moon. We always see the same side of the Moon. This is due to these tides and tidal locking. And the planets around these stars, this TRAPPIST-1 star, might also be tidally locked. That means there is always one surface dark, and the other one always heated by the star, and that makes a huge difference in temperature between the day side and the dark side.
Right.
And maybe having liquid water and life on this kind of planets is not that easy as we could expect.
Yeah. Now, apart from the absolute wonder and the expanding of knowledge, is there any practical use for this research for us here now on Earth?
Well, we are, even on Earth, we are looking at the other planets and doing what we call compared planetology. For instance, global warming is also something we learn looking at the other planets, like Venus, and we learn how the atmosphere can change the temperature on the planet itself. And looking at these exoplanets, we learned also a lot on the dynamics and the evolution of the planetary system and our solar system as well, and the migration of the planets. Right. So we learn a lot about the origin of life in general. So I don't know if it's really practical, but I think it's something everybody ask himself
Yes.
about that.
Now, I think Professor Stephen Hawking, the physicist, said recently we should actively start thinking about colonising other parts of space. How near are we with this, do you think?
Well, I think we can start already looking at our own solar system. If you would like to go to the closest star, Proxima Centauri, that we know, even at the speed of light, it would take a few years, but we cannot do that. With the best rocket we have, it would take thousands of years. Going to this Trappist one, it's about 1 million years. So we need to have either a very big change in the technology to go faster to another neighboring planet or star.
Right.
Or if not, well, maybe the best way is to look at the solar system and to see if there is or has ever been life in the solar system, Mars or other small satellites of
So not
Jupiter.
for now. Just very quickly, you have just a short amount of time. NASA have asked people to think of some names for these planets. Where are we on that? Any good ones? Pluto is making a bit of a comeback, isn't there? I heard there was a lot of backing, people who were angry that Pluto was demoted from being a proper planet.
In particular the US, but it has to be so. Pluto, the name Pluto still exists. It's not a planet, it's a dwarf planet. Okay. I have no idea for Trappist one, but maybe something looking like a Belgian stuff could be interesting. And
thank you very much to our astrophysicist, Daniel Hestroffer.